Welcome to our series of video lessons on GCSE physics. These are lessons designed so that if you miss a lesson, you can have a look at what you've missed. If you've come out of a lesson and you think, I didn't quite understand this, you can have another look. Or maybe if you're getting towards the exam and you're thinking and really don't quite remember that one, you need to go back and have a look through these lessons, okay? We're aiming to make each one sort of 5 to 10 minutes long, so it's a quick recap, okay? It's not the same as being there, but it does give you an idea, just a few reminders of what you might have done or missed in that lesson. Okay, so enjoy these. Hopefully you can pick out the ones that you most need to watch, and good luck. So our first one is about how heat is transferred in solids. What we did is we looked at a range of materials to see how they transferred heat. You will have done a bit of that in Key Stage 3, but crucially we also talked about the idea of particles, okay? So making sure that we can talk about in terms of the vibration of particles is a key part. Making sure that we can understand it in terms of the vibration of particles is a key part of this unit. So we know heat travels through solids by conduction. You'll have done that before. We know the basics. Metals are good conductors of heat. Non-metals are poor conductors or insulators. Sometimes there's slightly more complicated ideas about this, so you'll have seen this little demonstration. This is some paper wrapped around a bar, and the bar is one end is made of metal, the other end is made of wood. Okay, what happens here is the heat goes onto the paper's tightly onto the metal, so the heat that comes here gets conducted away by the metal, and the paper stays. The paper doesn't sort of set fire, but on this side the wood doesn't conduct the heat away, so this bit of the paper gets hotter and hotter and hotter, and you end up with a big scorch mark on this side. Okay, so this is just a simple reminder that metal is a good conductor and wood is a poor conductor or insulator of heat. Okay, here's a little animation to help us understand this. Here's our particles. Okay, when the rod gets heated, the particles at this end start to vibrate. The way the heat gets down the rod is that those particles collide with the next particles and so on. Okay, if you want this at a really advanced level, you might wonder why it is that the same sort of things are good at conducting electricity and good at conducting heat. Well, you'll come to understand over the next couple of years that this is to do with free electrons. So the electrons move down the wire. That's how electricity travels, and it's the electrons that can pass on this kind of energy, which is how conduction happens. Okay, but for now, as long as you're clear with the idea that the particles vibrate and collide with the next one, that's the general idea of how particles transfer heat in a solid. Okay, another crucial thing to understand here is that this particle that started off here, it's always going to be there. So the actual particles don't move along the rod, only the energy is transferred. Okay, so then we do a little experiment and you put different metals in here. You heat the metal at this end. Okay, imagine the particles in here are vibrating, so these particles start vibrating, they bump into these ones and so on. Eventually, when the heat energy gets to here, the Vaseline that's holding this drawing pin on melts and the drawing pin will fall down. The better it is at conducting heat, the quicker the time for the drawing pin to fall off. Okay, so normally in this we do copper and steel and brass, and we find that the time to fall off might be sort of 10 seconds and 100 seconds and 20 seconds, and our conclusion from that is that copper is the best conductor, steel is the worst conductor. An interesting thing to notice also here is that the steel tends to get red hot here, okay? A little bit like the paper and the wood in the first, and the metal in the wood in the first experiment. That's because the heat's not get conducted away, so actually the steel gets the hottest. Trying to put all this together into a few examples. So a saucepan is a classic example of conductors and insulators. You're heating the saucepan from underneath. You want the heat to get through into whatever's inside in here. So you need a conductor on the bottom here to conduct the heat through. But then when you pick the saucepan up by the handle, or you take the lid off, right, then you want an insulator so the heat doesn't get through here. Okay, this is a very basic kind of simple explanation. This is the hard one, right, to do with sitting on a bench. So I tend to draw this diagram. You sit on a bench. Okay, your body is nice and warm, so you've got nice warm bottom here. What happens? Well, if you sit on a metal bench, that heat gets transferred away from you and more heat comes out of your body and more heat gets carried away, so you end up with a cold bum. But if you sit on a wooden bench, right, you warm up the little bit of the bench here, but the heat doesn't get carried away, so it feels warmer to sit on. Okay, it's the same sort of idea I'm sure you've had if you walk with bare feet on a cold floor. Right, some materials feel a lot warmer than others. That's not because they really are warmer, it's just because you warm the little bit that you're touching up. And if it doesn't carry the heat away, if it's an insulator, like a carpet, for example, will be a very good insulator, right? Then it feels warm under your feet because it's not taking the heat away.